a long orbit around the center of the solar system, completing one orbit every 248 Earth years. We know that Pluto's radius is 1108 km. This means it is significantly smaller than all the planets in the solar system, even some other satellites, including the Moon. At the same time, observations of the celestial body's proper motion have helped calculate its mass with high precision. This mass is very small, only about 1.3 nh10 to the 22 kelvins, equivalent to 18 mph. The mass of the Moon? It is easy to see that Pluto has many similarities with small celestial bodies such as Eris or Caecina, in terms of characteristics. This is also the reason why it was removed from the list of planets in 2000X due to its long and elongated orbit. Pluto has a very long orbital period, only until 1989. This dwarf planet has just passed perihelion for the first time since it was discovered. It is closest to the Sun at a distance of 29.7 astronomical units. Since then, this distance has been continuously increasing and will reach its maximum value in 2130. By that time, the dwarf planet will be near aphelion 49.3 astronomical units from the center of the solar system. So Pluto is a very distant and faint space object. That is why it cannot be seen from Earth with the naked eye. And even in images from the Hubble Space Telescope, this dwarf planet looks like a hazy brown disk without any surface details. Of course, in such conditions, studying the celestial body accurately is almost impossible to solve. The problem. This topic, the New Horizons probe, was launched to Pluto in 2006. It took 9.5 long years for it to reach its destination. On the way, it sent back detailed main images of Jupiter. It was not until 2015 that the spacecraft reached the main target of the mission when it flew past Pluto. The spacecraft made about 400 observations, collecting more than 6 gigabytes of information, and it took more than 1 year to transmit this large amount of data back to Earth. Unfortunately, the orbit of the probe does not allow to take pictures of the entire surface of the dwarf planet. The reason is that New Horizons does not go into orbit around Pluto, but only flies by to be able to explore other space objects before going into the terrain. Features of this celestial body. We need to understand its internal structure according to the current model. Pluto has a large core with a diameter of about 1,700 km, consisting of a mixture of water, ice, and rock. This core is surrounded by a 300-thick ice mantle. There may be tectonic processes going on in the mantle, but they have not been thoroughly studied. This mantle is covered by a crust, which is a mixture of gaseous gases such as nitrogen, methane, and carbon monoxide. According to some hypotheses, Pluto's core may generate enough heat to melt part of the mantle ice, in this case deep below the surface of the dwarf planet. There may exist a very salty and toxic ocean containing large amounts of ammonia. The surface temperature of the dwarf planet is very low, not exceeding 60 decibels, equivalent to 213 decibels. Our exploration of Pluto will begin with its most prominent and well-studied feature, TBO Rayo. This large region is located at the equator of the dwarf planet and is shaped like a heart, giving it the unofficial nickname, the heart. Its size is up to 2,300 kilometers. It covers about 1/4 of the total surface area of the celestial body. The surface of Tomball Rio is heterogeneous. In the western part, there is a smooth and bright plain called Sputnik Planeta, with a diameter of 1,492 kilometers. The elevation map shows that this area is a large lowland covered by a thick layer of nitrogen pans, along with carbon monoxide and solid methane. These substances are bright in color, causing some parts of the plain to reflect up to 90 pH of light shining on it. There are also almost no impact craters here. This shows that this area is very young geologically. According to the main hypothesis, Sputnik Planeta formed about 100 million years ago when Pluto collided with a large celestial body, resulting in a giant impact crater that was filled with a hypothetical ocean inside the dwarf planet, which then rapidly froze. Some typical topographic features of the plane may be evidence for this. For example, there are quite a few smooth surface areas with sizes of 20 to 30 kilometers, with hills and depressions concentrated at the boundaries between them. This structure is similar to the convection zones that appear in any which fluid is heated from below. This may be indirect evidence for the hypothesis of a warm interior of Pluto. The radio tombs are surrounded by relatively high mountain ranges. To the west of the Nick Planius spot are the Hilary Montes, with elevations of up to 3,200 meters. To the south of the heart are the Tenzing Montes. Some of the peaks here are more than 6 kilometers above the average surface level of the dwarf planet, making it the highest mountain range found on Pluto. It is noteworthy that these rocks may be composed mainly of water, ice, and at low temperatures, like on Pluto, water ice is as hard as rock. Moving further south, we can see a deep basin surrounded by large ice and rock mountains. It is thought that this may be the mouth of an ancient ice volcano, and the surrounding rocks are frozen eruptions. Their chemical composition is of great interest in scientific research because once known, we may have a better understanding of the composition of Pluto. The eastern part of the radio is darker, and its surface is covered with many impact craters, indicating that this area is much older than spot Nick Planeta. Moving further east along the island equator, we will see a series of dark spots hundreds of kilometers in diameter. These objects are called maculas and are named after dark gods of